Okay, so one of the problems with hot glue is that it does ooze everywhere, and while I was waffling away there in the previous segment, it has oozed everywhere. But anyway, what I'm going to do is hold the motor in place with my finger and my thumb and forefinger, and just squirt in a little bit of hot glue just into the side there, and then come along and squirt in a little bit of hot glue into the side there. And then I'll do the same on the other side. I can tidy up the strings in due course, so that's not a big problem. Another bit of hot glue into the side there, and then just behind where my finger is there, I'll maybe come around this side. Squirt in a bit of hot glue there. Pop a wee bit extra just in there. Excellent, so that's all it needs. What I'm going to do now is just to tidy up the strings once it's dried in place, tidy up the strings of glue, and then we'll move on to the epoxy resin stage. Okay, so that's the hot glue totally set up now. I dribbled in a few extra bits and pieces of hot glue just to fill up some of the gaps there. In reality, I think you probably don't need to do it, as long as you let the epoxy set slightly so it's really gloopy, so it's not going to go through any holes. You'll probably be alright. It's belt and braces, but you might want to leave that step out. But anyway, we're on to the epoxy stage. So I've cleaned up all the little whiskers of hot glue, so there's nothing that's going to get in the way. I've made sure that these two wires are out. So I'm going to mix up some epoxy. Now I recommend you either use the 1 minute or the 5 minute epoxy, and you want this to set really pretty quickly. 5 minute just gives you a wee bit extra working time, but anyway, I'm going to mix this up. Make sure you get the ratios right, make sure you mix it up really thoroughly, so that when you come to pour it, you know that it's going to set fine. Okay, so I've mixed up some 5 minute epoxy. I've given it a really good mix there. It's getting to the consistency where it is just about slowing down its runniness. So I reckon we're probably about a minute away from being able to use it. So I'll keep giving it a good mix. I'll keep checking its consistency, and then we'll get pouring. Okay, I think that's probably us ready to go now. So I'm just going to carefully spoon this in, glob at a time. I find it's better with this to drop it from a height, and then it tends to find its own way into the correct bit without going anywhere else. You have to work fairly quickly with this. I think you would probably struggle to do this with 1 minute epoxy. Right, so I'm going to continue doing this off camera anyway, but the idea is just to go around here and fill in all of the gaps. Okay, so that's the epoxy resin stage all finished. The epoxy is in place, it is set up and hardened. The motor isn't going anywhere. If we flip it over, the gears here are still turning without any resistance. They're moving freely, so we know that there's not been any glue epoxy that's got into the inner workings. If I just bring it in closer here, you will be able to see, hopefully, the slightly darker or less or more opaque, I should say, areas are where the hot glue went first. So there was the 4 different places of that, and then we dribbled in the epoxy into the gaps, and then I just put a layer over the top there just to tie it all in together. One thing just to mention is that we have to be really careful when we're doing this to keep the wheels free, and there's not a huge amount of clearance between the wheel and where the motor is. So one thing that we want to be careful when we're dribbling in that epoxy is not to get any on the wheel or in the axles or anything like that. So the way that I do that is, rather than try to force the epoxy into that gap there, all I've done is dribbled in a bit here and a bit there and let it sort of gravity do its trick and draw the epoxy down. But I haven't built it up as much as I have around here, just to make sure there's ample clearance. But there is, and we're pretty much good to go. Now, just to clarify, this is just my approach for doing it. I know that there are different ways of doing it. There's the super glue route that I've seen, not my favourite. I wouldn't try it myself, but it might work for you. There's just using the hot glue. I think the Rolls-Royce approach is probably to create some kind of part 3D printed, made out of plastic card, something like that, where you can screw it down, which should make removal really easy if you ever needed to remove it. But given that these DVD and CD motors are they're designed to spin CDs an awful lot for a long time, really as long as you don't burn it out and you're careful with it, you shouldn't have to replace it. So anyway, that is how I've done it. So let's move on to reassembling the gears, and then once we've got all the gears back together, we can look at the electric side of it, wiring things up and getting it working. What I'm just going to do before we move on to reseating the gears is just to give these guys a wee clean up too. Now all I'm using is a little bit of isopropyl alcohol again, just on here, just to clean it up. They're not too bad actually, these ones, but I have had some that I have I've cleaned up which are really gunky. Some of the older Limas and so on have many years of happy playing behind them, and they need a good clean. So I'm just going to carry on cleaning these anyway. Once I've done that, I'll put them back into place. I sometimes put a little tiny bit of oil on just before I put them on, so there's some lubrication for the seats and the posts. But I tend to do most of my lubrication once everything is back in place. So anyway, I'll finish up with these cogs and then we'll come back to the reseating or reinstallation part. Right, so I've got the reference photo here, and we're just going to pop the gears back in. So in this particular model, these ones go in here. There we go. And the other on this side there. They fit in there. And then these ones go upside down between there. I'll seat them properly in just a second. And if you remember, these ones are also the ones that the nuts had to go back on. So I just pop the phone to one side. We know we've got them in the right way around now. So we need to get these little nuts here, and the nut spinner as well. So let's get that. There we go. Now you don't want to tighten these nuts too tightly. They need to retain the gears, but you know, they're not holding on for grim death. If you do tighten them down, they have a tendency, tighten them down too much, they have a tendency to warp the plastic or to bind so that the gears don't actually turn. There we go. Right, so I'll just finish this off anyway. I'll get them up to a nice tightness and then we'll come back to the next step. Okay, so now that we've got the bogie all upgraded, the motor's in, everything's working, it's ready to go, we need to look at how we're going to wire that up to the decoder. Now, you could just wire this straight up to the decoder. The problem is, however, that this is a 6-volt motor, and the decoder is going to be giving out roughly twice that, I guess. That means that A, this motor will burn out sooner than it would otherwise burn out, but also it's going to be shooting round the track, not just in a non-prototypical way, but like a rocket about to try to take off to visit the moon or Mars or something like that. So what we need to do is look at ways of slowing the motor down so that we're feeding it less voltage. Now there are a few different ways that you can do this. If you're just going to use this on a DC layout, then probably the easiest way to do it is to add a few diodes, which we've got here, into the circuit. Now these diodes drop about 0.9 of a volt each, so if we have 2, then you're dropping the best part 2 volts, so you'd be bringing it down to maybe more like 10 volts at the top end. So as long as you're not turning the controller all the way up, it will give you more headroom to work with. The other way that we can do it with a DCC decoder is to use CV values. Now I'm pretty sure it's CV5, but I'll double check and I'll put the CV value down here for you to see. But I'm pretty sure it's CV5. Now that talks about the kind of top range for speed. So if you reduce that down, what it effectively means is it won't pass quite as much power to the motor, so it won't spin as fast. So that's another way to do it. Or you can do a hybrid, which is what I'm going to do, which is use a decoder that has CV5, but also put in the diodes. So that basically means you're not relying quite so much on the DCC decoder to downgrade the power. You're using a combination. Now one thing as well, just to say quickly, is that not every decoder allows you to do CV5 tweaks. I think the cheap Hornby one, and therefore maybe the TTS decoder, which is the one I've got in, may well be one of those. So that's another good reason for sticking in diodes, because you never know, you might switch out a decoder in the future for one that doesn't have customizable CVs for this. So anyway, I'll stop going on about it. What we're going to do is use the diodes as a way to reduce that voltage. So that's what we're going to look at now. Okay, so how are we going to do that? Well, what diodes do is they're a bit like a one-way valve in electricity, in simple terms, that they allow the power to go one way, but they don't allow it to go the other, or the voltage, or the current flow is a better way to put it. So they act as a one-way valve. So that's fine if we put one on one side and we put one on the other, that means that it'll flow one way. But if we want to then reverse the loco and make it go in the other direction, the power would be going back against those diodes and couldn't flow. So what we need to have is, we need to have two diodes in either wire, one facing one way, one facing the other, so the energy will flow, or the current will flow one way, and then if we reverse the locomotive direction, it will still be allowed to reverse back the other way as well. I'll do a quick diagram and pop that up on the screen so that you can see what I'm talking about. In fact, when at post, I may already have put it up on the screen as I was talking about that. But it's perhaps simpler than that I've explained it. So the way that I'm going to do that anyway is I've just, I got a bit of copper clad board. I cut just a little kind of, almost 2 centimetre by 1 centimetre strip. And then I cut it like a St. George's flag. So there's 4 bits of copper, and I will put 2 diodes on one side, one facing one way, one facing the other, and I'll put 2 diodes on the other, one facing one way, one facing the other, and then we'll attach the motor wires to one side, and then we'll attach the DCC chip motor feed wires to the other side. So I'll cover all this again as we're going along, but what we want to do now is to fix the diodes onto here. That's the first part. So I'll get the soldering iron out and we'll come back and we'll do that. Okay, so we've got the soldering mat out and we've got the diodes here. I'll just take these out of the package. Now, as I mentioned right back near the beginning of the video, these are surface mount diodes. They're just rectifier diodes, just standard rectifier diodes. You could use push hole diodes, so that, you know, the traditional ones that look a bit like resistors, but they're diodes with the legs. You could twist those together as well, but they probably wouldn't be quite so easy to use on copper clad board, because you need to drill holes through for them and so on. So this is what I'm going to use anyway. So the way that I'm going to do this is to get one way round, like that, and then one the other way round. Now, the way that you can tell diodes round is that they have a white line at one side and no line at the other. So we want to have the white line facing that way, and then a white line facing this way, and then the same on this side, white line facing that way, and the white line facing this way. So that's what I'm going to do now. Sorry, I should have said there, I've just taken them off again quickly. Best to first put down a little bit of liquid flux, just to make all the soldering go happily. So just a little blob on either side like that. That's all we need. So I'll then pop these diodes back on again. One that way, and one that way, and then we'll do the same over here. Okay, great. So if you have seen my previous videos, you will probably have noticed that the way that I deal with these tiny little surface mount gizmos is to tack one side first, then solder the other sides correctly, and then properly solder the other side again. And the easiest way that I've also found to do that is to use a little bit of blue tack on one side to hold them in roughly the right place. Now, there's no awards for really pretty soldering, so as long as you get the job done, that is the main thing. I wouldn't worry too much about what it looks like. Just the main thing is to avoid getting any shorts or anything like that. So that now that they're tacked down with a blue tack to start off with, there we go. Great. That'll do. Doesn't need to be any better than that, he says as he readjusts them slightly. Great, that will do. Right, so what I'm going to do now is bring in the soldering iron, bring back the the solder again. I'll just tin the end, give it a quick clean first actually. There we go, just tin the end there. And then heat up the copper here. Flow some on there, there we go. Same again here. Great, that's that side done. It will take a little bit of time when you're doing soldering like this because there's quite a lot of copper. So you need to get that pad heated up. And I have to say, I've got a needle nose soldering iron here, which is great for some of the work that I do, but it's not so good for heating up a big pad of copper like this. But we'll make do and we'll get through it. Anyway, that's these ones tacked, so I'm going to remove the blue tack from the other side and then I'll solder the other side on as well. Excellent, so that is all of the little circuit board soldered up now. We've got a diode going one way, the other way, one way, the other way. Now I've put quite a lot of solder on this either side of these, and the reason is because I'm going to tack on the wires to the motor and the decoder, so I want to make sure there's plenty solder on there to slap the wire into. If it was just normal soldering, I wouldn't put on as much solder as this, but anyway, that's why we've done that. So what we want to do now is to bring in the chassis that has the decoder, and also bring over the bogie as well with the motor, and start to put it all together, and then we'll get all this soldered in line. So if you recall right back at the beginning of the video, we desoldered the pickup wire for the front pickup just to make it easier to get the motor in and about. So what we want to do first of all before we do anything else is just to solder that back on. It's going to be easier doing it just now than doing it later. So we'll bring the soldering iron round, pop that down there. There we go, excellent. That's that in place, and now we just want to feed the bogie back up into position again here. There we go. That's in position there. Oops. And we will bring in this bogie piece here, and I'll spin this upside down, screw this back in again. So I'll do that just now. Okay, so I've placed the bogie fascia back on top again. Now, the previous owner of this one cut off the coupling. So if you do have one of the coupling, you'll have a sort of D tension lock coupling here. So obviously that's the one that needs to go out. But on this particular one, there is no coupling to go out, so we don't have to worry about the orientation. So there we go, just screw that down again. And the same on that side, tighten that one up. Excellent. Great. So that is the bogie back together again. The front pickup is also soldered in. So we'll turn our attention to getting these 4 wires connected back up together. Right, so I've had a little look around to work out what the kind of best arrangement is going to be. And I think having the diode combination fixed to the front of where we've got the decoder here, or just onto the floor, somewhere in around here anyway, that will give plenty length for the wires on the motor there, and also it'll mean there's absolutely bags of room for the wires coming out the decoder too. So before I can put it in place anyway, I'll get these wires soldered on this way around. So it doesn't matter at first which way around these 2 motor wires go, but we just need to make sure that we line them up correctly with the directional wires on this side. Right, so I've just used this glass. This is oven-proof glass. So it'll be fine with any heat round it. I've just put this here so I can get this up to a good working height. Wee blob of blue tack underneath just to hold it in place, and I'll start soldering. So all we need is just a little, in fact I'll put a tiny bit of solder on the end here just so we can freshen up the tip of the soldering iron. So we just need a little blob here. There we go. And again, because there's a lot of copper here, it might take a little bit of time just for the solder to start flowing. And then we'll put the second one over here. There we go. Just reflow that again, I think. There we go, that's a better joint. Great, okay. Wee bit hot there. Yeah, do remember that if you have been leaving the soldering iron on it for longer, it will then remain hot for a bit longer too. So anyway, a little bit of a burnt finger, but we're all good. Right, okay, so I'll just go and refresh my memory as to which way around these wires need to go, and then we'll get these hooked up, and then we'll be within touching distance of giving it a test run. Okay, so I have now checked my notes, and it is the orange, or in Hornsby's case, the salmon pink wire that wants to go to the brown on this particular motor. But you will have to check your own, because your motor could conceivably have the wires switched the other way around. It shouldn't, but you never know. It's not the end of the world. If you do wire it up the wrong way, you can tweak it with CV settings to make it go in reverse. But it's better to try to get it right from the get-go if we can. So, orange to brown, so we'll just bring in the iron here. There we go. Sorry, I'm left-handed. Normally I would be doing this slightly differently, so it's not enabling me to get quite as good a solder joint as I would normally try to get, but well, it's a good enough joint, it's just a wee bit messy. But anyway, I'm just going to trim this other one down. There's a big blob of solder on the end here, which we don't need, so that's it trimmed down. So grey to blue is the way that we're going to do it on this side. So let's just get this round there. I think it probably could do with a little bit extra solder, so we'll take that up there. And then let's go. Excellent. So there we have it, we've got it all soldered up. So I'm just going to put a little wrap of Kapton tape around that just to stop anything shorting out. And I'm going to use a little bit of black tack just to pop it down here next to the decoder, or possibly just above the decoder. I'll see what works best. Once I've done that, we'll bring in the test track and we can just double check that it works. Okay, so I've got the diode PCB wrapped up in Kapton tape. I was going to stick it on over here, but actually sticking it with black tack on the back of the, let's just tilt this round, on the back of the actual motor housing worked out much better. There's plenty of slack here in the wires, so there's no problem with anything catching. So we're pretty much ready to give it a test. So it's on the test track, as you'll see. I've got the multi-mouse here. It's still on the default 03 address, so let's just slap it on and see how we get on. Whoa. Right, so as you can see, it does go slightly faster than you would normally hope for when you turn the dial. So you will need to be quite careful in how you adjust it. The diodes are doing their thing, they're reducing the amount of current voltage that's getting through. But there still is, it's still a 6 volt CD motor being fed potentially up to 12 volts, so do keep that in mind. But it seems to be working reasonably well, sounding pretty smooth. There's not too much a rattle. It's definitely quieter than the old Ringfield motor, so that's nice too. See how we go. So it's not totally silent, but it's certainly a lot quieter than the old motor. But I'm really pretty pleased with how this has come together. I'll give it a proper run-in on the track on Strathpeffer Junction, the layout, once I get there. I know that there's only so much that you can do on a rolling road like this. But let's go in the other direction just to see as well. There we are. That's slow it down a bit. That's us going in the other direction. Sorry, I forgot to check that. It does work both ways. Okay, great. So we've got there. We've got the decoder working with the new CD type motor that's in there. We've got the diodes working to drop a few volts, about just under 2 volts altogether. Yeah, really happy with that. This is probably about the 4th Lima conversion I've done. They tend to be pretty similar, but everyone will throw up its own little peculiarities, and some go slightly more smoothly than others. One thing just to mention actually is that this video was put together over a period of hours, and while I was having my lunch and was reading up on it, I do notice that some people are now advocating that you don't put in a bush to support the pin of the motor, because sometimes that bush can bind. Now, I've never had a problem with it binding when I've done it. I've been careful to line it all up to make sure that everything is working smoothly, but that could be an issue. So it is something that you can leave out permanently, but I think the recommendation, and I think it is Phil in his channel, recommends that you do use the brass tubing to align the motor properly, and then once the glue has dried or whatever other fixing mechanism you might use, you can remove that brass tube. So it's, rather than being there permanently and rather than having to solder it all in place, it's just a temporary measure to help find the right position for the motor. But anyway, that's the conversion finished. I'm not going to put the lid on it because I've got one final thing to do with this loco while its lid is off, which is put in a better speaker. So I'll leave the video here for now. Hopefully you've enjoyed it. Hopefully you've been able to work out what it is that I'm trying to explain and show you. If you've got any queries or comments or any suggestions, if you think there's a different way or a better way to do it than I've done it, then please feel free to leave comments and so on down in the comments section below. If you have enjoyed this, you've got something out of it, please feel free to give it a thumbs up. If you've not already subscribed to the channel, please feel free to do that as well. But all that remains to be said anyway, until next time, cheerio for now. Bye bye.